Hello there, Engineering Science, Mr. Young here, just looking at a little bit more about energy here, and just looking at work done this time, and how to use the work done formula to be able to solve some calculations. So we need to know what work done is measured in, that's an energy, so we'll be able to find that out, and we'll be able to work out what the force and what meters are measured in as well, and how to calculate these things out. If I go into the next slide here, you can see that work done is also known as work energy, or EW in brackets here at the top. Okay, so you know that energy is the ability to do work, and you can see that this point is either an object being pushed or moving from one point to another. So you've got work energy at the top in this formula triangle down the bottom here. That's measured in joules. Remember, energy is always measured in joules. And then we've got force down the bottom, and distance as well. And force is measured in newtons. Remember, weight is a force, and mass is in kilograms. Well, it's not in this bit here, but it's just this difference between force and mass. So force is measured in newtons, and distance is always measured in meters. So we're going to use this formula triangle now just to try and work out a couple of problems, 3 problems in fact, on work done. So just looking at a couple of work done examples here. We'll take number 1 here. We'll look at, obviously we looked at just before that work done, or work energy, is equal to force times distance. This is measured in joules. Force is newtons, and distance is always in meters. Okay, so we'll take a first example here, maybe a car. Car has a force of 10 newtons, and it travels, so we say 5 meters. So what is the work done? Question mark. Right, so looking at a formula triangle, EW, force times distance. If we cover up the work done, or work energy, it's the same thing, that's why I'm referring to them kind of both the same way. Don't know if you can see that underneath. That is equal to force times distance. So we can state that first, always state the formula. Force times distance, and that's equal to the force of 10 newtons times 5. And everyone's probably worked this out already. And it's going to be 50 joules. So always make sure you put units in, and always make sure you lay them out so that you can see that the actual work done is going to be 50 joules in this case. So that's example number 1, quite straightforward, looking at just the multiplication of these two. You can work out the second one as well. You can work out another way of maybe saying, let's have a look, a dog has a work energy of 10 joules. It travels 2 meters. What is the force? What is the force of the dog? What's the maybe not the best worded question, but you'll get the idea that we're looking at the force here of this dog. It exerts a work energy of 10 joules and travels 2 meters. So we can find this out by covering up force in this case. Excuse me. And that's going to be equal to work energy divided by distance. Okay, so you can work that out. So we can, the force is equal to EW, work done, work energy, divided by distance. So that is 10 divided by 2, which again is just 5 newtons. We're looking at force this time, so that's equal to 5 newtons. Okay, so there's different ways you can work this out. We can work out a distance now. If I just move slightly over here for number 3, so that's one way of doing it. That's the second way, and we'll look at a third way. In fact, we can look at a fourth way actually, just to see if we've got time. This time we're looking at a distance, so we've got a car, a dog, a tiger. Rawr. A tiger
exerts, which I didn't put, force of, well, I will say 20 newtons, will go crazy. It has a work energy of 10 joules. So we'll find out what distance it travels. What distance does it travel? What distance? I had to move that a wee bit there. Distance has it moved or travelled. Right, so target exerts a force of 20 newtons. We've got work energy. We're looking for a distance this time, so if we manage to cover up the distance, we've got work energy divided by force. So in this instance here, we've got distance, covering up the distance, we'll cover that there, work energy divided by the force, So 10 joules is our energy, or work done, divided by 20, so that's going to be a half, 0.5, or just the old way. That's 0.5, so that's 0.5 metres, remember, because the distance is in metres. That's also equivalent to 50 centimetres as well. So 3 different ways of working it out. You may also get a question, if I flip this over here, you may also get a question, surprise question. Right, what are we going to choose this time? Banana boat, one of those things that goes in the sea, has a mass of 100 kilograms. We'll just say that. It's probably much more than that if it's fully loaded. And moves a distance of 10 meters. What is its, we'll just say work energy or work done, say work done. Okay, so there you go. How are you going to work this out? You have a mass, so work done does not have, as force times distance. It doesn't have a mass. So how are you going to work this out? Because you can't just plug that into there because it's wrong. Mass is not a weight. Remember, force is a weight though. So there we go. There's a clue for you. So remember, mass times gravity is weight is equal to mass times gravity, and weight is a force which is measured in newtons, and this is measured in newtons. Remember, that's meters, and this is joules, just in case we're getting confused here. So what we're going to have to do first is to use our weight, mass times gravity. So we're going to have to use our 100 times 9.8. It's going to give us 980 newtons. Okay, so that's going to be our weight or our force, because they're both measured in the same thing, and weight is a force. So this will work in this instance. So now, once we've worked that out, using this equation, because sometimes you have to use multiple equations to work out problems, and they do this on purpose so that you have to think about it. Once you've got that, you can actually easily use our work done formula, or work energy is equal to force times distance. We have our distance, so we're going to have 980 times 10. So our work done is going to be 980 times 10, 1,800 joules. Okay, and that's simple as that, just multiplying these two out now, and that's also equal to 9.8 kilojoules. So we can simplify it again, and that's it. So you might get a question something similar to that.